Alrighty. Today we're going to have a short lesson on one new type of factoring. So last Friday you saw another new type of factoring. It's called factoring by grouping. And today we're going to start working on cubes. So numbers like 2 to the third is 8, 3 to the third is 27. And we're going to take a look at that pattern as we're trying to figure out how do we solve any algebraic situation. How do we solve these polynomials that we've been given? I do want to remind everybody that even though it landed on a Friday, we are still going to take the test of sections 5, 1, 2, and 3 on Friday. So I'm going to do the Google Meets according to the Friday schedule, and I'll remind you about the Friday schedule on Thursday. So I'm going to do the Google Meets like normal so that your folks don't have to monitor you while you're taking that test. But it's just over the 3 sections, 5.1 to 5.3. So we're going to take 2.5 to 3 days here, probably full 3 days on section 5.3. Then we'll do our practice test on Thursday, and then we'll have our Google Meets for the test of 5.1 to 5.3 on Friday. So this one, like I said, Friday's lesson was this really interesting. I just love factoring by grouping because we have to trick our brain into seeing factoring by grouping. In fact, let me just do one of these to talk you through it and remind you what it was. 98% of people on the planet, if you give them groups of 3 numbers, they can remember them. I mean, it's like your locker combination. It has 3 numbers that are broken up. Your social security number is broken into 3 different pieces. Telephone numbers, area code, and then the prefix, and then the phone number in the 4 in the back. Always broken into 3s because almost everybody on the planet can do that. But it's amazing how when we go to 4 terms, for almost all of us, our brain says, nope, too much, done. I can't see it. So what we have to do is factoring by grouping is tricking your brain. The first thing you would do with any of these is always look for a greatest common monomial factor. So 8, 20, 6, and 15, there isn't a number that's going to come out of all 4 of those, and it has to. So then what I do is say, all right, brain, I'm going to get you to see this. I'm only going to group the first 2 together, and I'm only going to group the back 2 together in hopes that I can make you see factoring by grouping is going to work. So now with 8 and 20, I realize, well, I can take a 4 out of that. And this has an x cubed and an x squared, so I can take an x squared out of it. And that will leave me with 2x minus 5. And then in the back, I do the same thing. I just think about the 6x and the minus 15, and I realize I could pull a positive 3 out of that, and that would give me 2x minus 5. And this is where we say, oh my gosh, look at that. 2x minus 5 was really in all of these. I couldn't see it because my brain couldn't think of 4 numbers at one time, 4 terms at one time. But now I know it was there. So 2x minus 5 really was a factor of the entire thing. And what did I have to multiply that by to get it back? Well, these leftovers, 4x squared plus 3. So that was Friday's lesson, was using factoring by grouping to get these factored. And today's is just sum and difference of 2 cubes, which sounds really basic. And it is, as long as you can think your way through the formulas. Some people just memorize them, but you know me, I don't like memorization in math. I'd like it if everything worked logically, if you could think your way through it. So if we have a cubed plus b cubed, we notice, hey, this number is something cubed and this is something cubed. If we have this, I would hope that most of us would say, you know what, there has to be at least one a plus b in that thing. I mean, for goodness sake, it's a cubed and b cubed. That has to work. And then just work backwards. So ask yourself, a times something has to come out to a cubed. That something would be a squared. b times something has to come out to b cubed. That something is b squared. But now, when I multiply these two back together, I can't get a middle term. So this and this are going to have to be opposites of each other for that to happen. So if this is a plus, I'm going to need a minus AB in the middle in order to make that happen. So again, think about it logically, but think about it in terms of a times what would give me a to the third? Has to be a squared. B times what would give me b to the third? Has to be b squared. And I can't have a middle term, which I would have, but if this is a plus, I'll make that middle term a minus, and then I'll have it covered. And then you just use that same logic for a cubed minus b cubed. So you say to yourself, gotta be at least one factor of a minus b in there. I mean, there's three of them, for goodness sake. Has to be at least one. And then this would have to be an a squared. This would have to be a b squared. Doesn't look like a b squared. But again, I can't have a middle term. And this one has a minus in it. So I'm going to need to make this a plus ab to make sure that I don't have a middle term when I multiply all of this through. So like I said, I'd prefer that you didn't memorize it. If you have to, you do. But I think that you can get there logically. So this is showing why this pattern works the way that it does. But I don't want anybody to get confused by that. What they're trying to do is they're trying to show we really could kind of use factoring by grouping to get this one to work out. So that's another way that you can think of it. But when you break it down, notice how they had to add a whole bunch of middle terms in there. And that's one of the reasons that I just try to teach, you know what, think logically about where that formula comes from. So how are we going to know that these are these special sum and difference of two cube problems? Well, they're going to have cubes. So when I look at this one and it says factor, I notice, well, this is x cubed. And then I wonder, is there something cubed that would give me 125? And you could use your graphing calculator to figure that out. Under math, number 4 is cubed root. So if we want to know if 125 is a perfect cube, we take the cubed root, and by golly, there it is. 5 times 5 times 5 gives you 125. And then we have to remember the formula. And this one has a plus, so it would be a cubed plus b cubed. Think through it logically, like I said before. Gonna have to have an a plus b, an a squared, and a b squared. But then I want to make sure that that middle term has the opposite sign of whatever this has, so that when I multiply it through, I don't get a middle term. Well, now all I need to know is what's a and what's b. That's what I just found. This is a cubed, and this is b cubed. So all I have to do is everywhere I see an a, I'm going to put x. Everywhere I see a b, I'm going to put a 5. And if I have to simplify it a little bit, then that's what I'll do. So it will be x plus 5, and then a squared would be x squared minus a times b would be x times 5, which is 5x. And then in the back, b squared, well, 5 squared is 25. Now, the question that always comes up is, can we keep factoring? That second one has a squared in it. Whenever there's a squared in it, we should always check and see, is that something that's going to be factorable? Can I keep going? The answer is about 95% of the time we're going to be done. There's not going to be anything else we can do there. But we need to check, and here's how we check. Hopefully, when you look at b squared minus 4ac, your mind says, wait a second, didn't we already learn that? Because that's the discriminant. Now, if b squared minus 4ac comes out to be a perfect square, then it's factorable. That's the only way that we can keep going. So let's check and see. A is 1, B is -5, and C is 25. So this will be -5 squared minus 4 times 1 times 25. -5 squared is 25 minus 4 times 1 is 4, and 4 times 25 is 100. Well, that's certainly not a perfect square because it's negative. You can't have negative perfect squares. So that means we're done. That is how you factor x cubed plus 125. Finished. Let's go to the next one. And I think I need that lower. That's probably in the glare spot there. All right, first things first, 8m cubed plus 343. Well, if I can take an 8 out of the whole thing, I would try. So you'd take 343 on your graphing calculator, and you'd try 343 divided by 8. And it's not going to work out nice. It's a decimal, 42.875. Then you think, well, how about 4? 343 divided by 4? Well, that's not going to work because you're dividing an odd by an even, and it doesn't. And you try 2, and it doesn't work either because it's an odd divided by an even, and that's not going to work out perfect. But then you start thinking, wait a second. 2 times 2 times 2, that's 8. So this is 2m cubed. 343, well, we haven't seen that one a whole lot, so maybe you grab your calculator and you hit math, number 4, cubed root, 343. Oh, that's 7 cubed. 7 times 7 times 7. And then you think about the formula. This is a cubed plus b cubed again. So it's going to be a plus b, because this was a plus, a squared in front, b squared in the back, and then a middle term that's going to be the opposite of what we see in the first set of parentheses, so minus ab. And then we'll plug them in. So a is 2m, and b is 7. Let's see what we get. It'll be 2m plus 7, because it's a plus b, and then we'll have 2m, now we have to be careful, 2m, the whole thing squared, so that's going to be 4m squared, minus 2m times 7 is 14m, and then b squared, 7 squared is 49. And again, if we wanted to know, do you think we could keep going? 4m squared minus 14m plus 49. We'll do b squared minus 4ac, which is negative 14 squared minus 4 times 49. And you could always punch that in. So what did we have? Negative 14 squared minus 4 times 49. Yeah, that's a negative again. That's not a perfect square. So that one is done as well. And like I said, about 95% of the time when you use this formula, that's going to be all you can do. It's very rare that you end up being able to factor that second quadratic back there, that second parentheses. Alrighty, so looking at example 7, n cubed minus 216. Well, it's pretty easy to see that this is n that's been cubed. But 216, well, that's another one we haven't worked with a whole lot. So, math, number 4, 216, 6 cubed, 6 times 6 times 6. but this time it has a minus in between. So it's going to be a minus b, a squared in front, b squared in back. But make sure that the middle term is the opposite of what we see in the first set of parentheses. So this one is subtraction. This is going to have to be a plus ab this time. And a is n, and b is 6. I better put this on here so when somebody looks at the notes later, they'll know what on earth we were doing. So now we need a minus b, which will be n minus 6. Then we need a squared, which is n squared, plus a times b, plus 6 squared, which is 36. Now, this one, since it doesn't have a number in the front, another thing you could do is sit and think, are there two numbers that multiply to 36 and add to 6? So 36 has a lot of factors. You've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, but you could run through them all and you're not going to find it. This is done. That's why I usually say use the discriminant because it's so much faster. 6 squared minus 4 times a was 1 times 36. And most people will look at that and go 36 minus, oh my goodness, no, that's going to be negative. So not going to be factorable. Nothing I can do. All right, now, example 8. 27x cubed minus 64. So again, you should think, well, I wonder, could I divide both of them by maybe 9? But 64 is not divisible by 9. How about 3? No, 64 isn't divisible by 3 either. But that has to be our first check. It's always greatest common monomial factor. And then we check to see 27 and 64, are they perfect cubes? Math, number 4, 27. Maybe you already knew that one. We've used that one quite a lot. And then math, number 4, 64. So it's 3 cubed and 4 cubed. So this is 3x cubed, and this is 4 cubed. And this one again has subtraction. So in that first set of parentheses, we'll definitely have subtraction. A times a squared will give you a to the third. B times b squared will give you b to the third. But we need that middle term to be the opposite of what we see here. So this is a negative. This needs to be a positive. We're going to put a 3x in for a and a 4 in for b and see what we get. So it will be 3x minus 4. And now here's that first term. We have to be careful with that one because this one not only has the x, it also has a 3. So 3x, the whole thing squared, would be 9x squared. And that will be plus 12x. And then 4 squared in the back is 16. Again, try b squared minus 4ac. 12 squared minus 4 times 9 times 16. And yeah, you can probably see that, 4 times 9 times 16 is going to be more than 144. So it's going to be negative, which means we're done. So this is the new pattern that we needed to see today. After that, I don't think we do any more. Nope, we don't have any more factoring patterns. We've seen them all after we've seen the sum and difference of two cubes. So I don't want to get going on anything else today. I need you to get used to the sum and difference of two cubes pattern and start using that math button number 4. Again, if you don't have your own graphing calculator, make sure you're using that Rapid Identity app. Apparently, while I was gone last week, there was some trouble with Rapid Identity, but it's supposedly all fixed now, so it'll be on there. And I don't want you to follow the directions that are in the book. And I know this says juniors, but this is going to be for everybody. section 5.3 day 1, page 301, 11 through 19, but just factor, don't solve. In fact, as I see, we've only got, 13 people here today. I'm going to know if people are copying out of the back of the book because they're going to be writing down answers. The book says solve. I don't want you solving. I want you to practice factoring. So 11 to 19, just factor, and then 61 to 67 has a little bit of review in there. Absolutely feel free to stay on today and work through this in case you come across a number and you're like, oh my gosh, I don't have a clue what I'm supposed to do with this. But just practice those 2 new factoring patterns today. And yes, I'll keep it open, so if you want to go off and do some work, and then if you have a question, you can pop back in before 10:45, and I could help you with it.